In the mist-laden forests of the Himalayas, a quiet specialist moves through the canopy. Known for its striking appearance, the red panda conceals a biology shaped by precision, scarcity, and survival. The animal commonly referred to as the red panda, Ailuridae fulgens, occupies a narrow ecological niche along the eastern Himalayas and southwestern China. Despite its name, it is not closely related to the giant panda. Instead, it represents a unique evolutionary lineage, classified in its own family, Ailuridae. Genetic and morphological studies confirm that its closest relatives are neither bears nor raccoons, though it shares superficial similarities with both. This distinct classification underscores a long, independent evolutionary history that has shaped highly specialized adaptations. One of the most defining characteristics of the red panda is its diet. Although taxonomically a carnivore within the order Carnivora, its feeding behavior is overwhelmingly herbivorous. Approximately 85 to 95% of its diet consists of bamboo. However, unlike herbivores such as ungulates, the red panda lacks a multi-chambered stomach and does not possess the specialized gut microbiota required for efficient cellulose digestion. As a result, it must consume large quantities of bamboo daily, often up to 20 to 30% of its body weight, to meet its energy requirements. This inefficiency imposes strict constraints on its behavior and habitat selection. To compensate for its limited digestive efficiency, the red panda has evolved several anatomical adaptations. Among the most notable is the presence of a modified radial sesamoid bone, commonly referred to as a false thumb. This structure functions as an opposable digit, allowing the animal to grasp bamboo stalks with remarkable dexterity. The same adaptation is observed in the giant panda, though it evolved independently, a striking example of convergent evolution driven by similar ecological pressures. The red panda's metabolism is unusually low for a mammal of its size, an adaptation that reflects the low caloric value of its primary food source. Studies indicate that its metabolic rate is significantly reduced compared to other carnivores, enabling it to conserve energy. Behavioral patterns further support this strategy. Red pandas spend a substantial portion of their day resting or sleeping, often curled up in tree branches with their long, bushy tails wrapped around their bodies for insulation. This tail, marked with alternating reddish and pale rings, serves both thermoregulatory and balance functions, particularly in arboreal environments. Arboreal locomotion is central to the red panda's survival. Its semi-retractable claws and flexible ankle joints allow it to descend trees headfirst, a rare ability among mammals. This adaptation provides a critical advantage in evading predators such as snow leopards and martens. By retreating into the canopy, the red panda reduces its exposure to ground-based threats while maintaining access to bamboo resources that grow at varying elevations. The species distribution is closely tied to temperate forests at altitudes ranging from approximately 2,200 to 4,800 meters. These environments are characterized by dense understories of bamboo, interspersed with old-growth trees that provide nesting sites. Red pandas are highly sensitive to habitat fragmentation. Even small disruptions in forest continuity can isolate populations, limiting genetic exchange and increasing vulnerability to local extinction. Current estimates suggest that fewer than 10,000 mature individuals remain in the wild, leading to its classification as endangered by the International Union for Conservation of Nature, IUCN. Reproductive behavior in red pandas reflects both environmental constraints and evolutionary strategy. Breeding typically occurs between January and March, with a gestation period that includes delayed implantation, a reproductive mechanism in which the fertilized egg remains dormant before implanting in the uterine wall. This allows birth to coincide with favorable environmental conditions, particularly the availability of fresh bamboo shoots. Litters usually consist of 1 to 4 cubs, though mortality rates can be high, especially in the early weeks of life. Maternal care is intensive. Females construct nests in tree hollows or rock crevices, lining them with leaves and moss to provide insulation. Cubs are born blind and remain entirely dependent on the mother for several months. During this period, the mother frequently relocates them between multiple nests, a behavior thought to reduce the risk of predation. By approximately 90 days, the cubs begin to explore their surroundings, gradually transitioning to solid food while continuing to nurse. Communication among red pandas is relatively subtle, relying on a combination of vocalizations, scent marking, and body language. Scent glands located at the base of the tail and on the soles of the feet produce chemical signals used to establish territory and convey reproductive status. These markings are often deposited on tree trunks and branches, creating a chemical map of the animal's environment. Vocalizations include soft whistles and squeals, typically used during social interactions or when alarmed. Climate change presents an additional layer of complexity to the red panda's survival. Shifts in temperature and precipitation patterns directly affect bamboo growth cycles, potentially reducing the availability of this critical resource. As bamboo species exhibit synchronized flowering followed by die-off events, any disruption to their regeneration can have cascading effects on dependent species. For the red panda, whose dietary specialization limits its flexibility, such changes pose a significant long-term threat. Conservation efforts have increasingly focused on habitat preservation and connectivity. Protected areas across Nepal, India, Bhutan, and China aim to safeguard remaining populations, while reforestation initiatives seek to restore degraded corridors between fragmented habitats. Community-based conservation programs have also proven effective, integrating local knowledge with scientific research to reduce human-wildlife conflict and promote sustainable land use. In captivity, red pandas have become ambassadors for conservation awareness. Breeding programs managed through international cooperation have achieved measurable success, maintaining genetic diversity and supporting reintroduction initiatives. However, experts emphasize that long-term survival ultimately depends on preserving the integrity of wild ecosystems. Thank you for exploring the hidden life of the red panda. Subscribe to continue discovering the science behind Earth's most remarkable species, and join us as we uncover the next story waiting in the wild.